Hello everyone. Today we're going to be learning about the inverter and the buffer gate. So here's our typical inverter. Looks like this, triangle with a dot on the end. And this is what our buffer gate looks like. Exact same thing, just minus the dot on the end. So let's look at the inverter gate first. Inverter gate has input X, output Y. Let's say we input a logic 0 or a low. The inverter is going to flip that into a logic high or a 1. Now the other case, if we input a 1, the inverter is going to output a 0. So hence the name, the inverter takes whatever your input is and flips it, and that's your output. So here we've got a CMOS circuit example, and let's go through and verify that this is actually an inverter. So if we input a 0 here and track it through the circuit, if we go up to this PMOS right here, we're going to see that with our 0, this PMOS is turned on, thus connecting VDD to Y, giving us an output of logic high. Now with that same input, just to verify, if we go down to this NMOS here, this NMOS is off, and there's no connection between Y and ground. Okay, now the other case, input a logic high or a 1, track upwards, go to this PMOS. This PMOS will now be off, so no connection will be made between VDD and Y. If we go down, this NMOS will now be on, and there will be a connection between Y and ground, giving us an output of 0. All right? Now, here's our buffer gate. Again, input X, output Y. So if we input a 0 into the buffer, our output will also be a 0. Okay? In the other case, if we input a 1, our buffer's output will again be 1. So the buffer essentially connects your input to your output. Let's look at another CMOS example. So if we input a 0 and track upwards, this NMOS, we'll see that the NMOS is turned off. There's no connection between VDD and Y. If we go down to this PMOS, there is a connection between Y and ground as this PMOS is turned on, so our output will be 0. Now, if we input a 1, go down again to this PMOS, PMOS will be off, no connection between Y and ground. If we go up to this NMOS, it will be on, and there will be a connection between VDD and Y, giving us a logic high output. Now, you may be wondering, what's the point if it just connects input to output? Now, there's one major use case that you'll find buffers used in. So say you have a circuit A, and it's got a current capability of 5 milliamps, and you have your load here, whether that's a fan or LEDs, and it requires 15 milliamps to drive. Well, you're 10 milliamps short, right? So a buffer is great for current amplification. If you were to put a buffer in here, depending on the ratings, you could now drive this load with the exact same circuit, just adding a buffer.